Welcome to this video on From Ingestion to Intelligence, where we explore how Memdog ingests, enriches, and makes data queryable. Our powerful system includes 3 ingestion paths, a 6-layer classification, 42 AI agents, 5 search modes, 4 re-rankers, and RAG chat with citations. The pipeline at a glance involves 5 main steps: ingest, classify, enrich, store, and query. Data is classified, enriched by specialized agents, and stored in multiple queryable indexes. This process is designed to handle data from any source efficiently. Data enters our system in 3 ways. First, through channel webhooks, with 33 channel adapters normalizing messages from various platforms into a universal envelope. Second, via direct API upload for files, text, or URLs. Third, through the universal envelope for structured ingest, allowing bypass options for pre-processed data. The universal envelope is a single container that standardizes any data type for the pipeline. It contains 3 main components: origin, detailing where the data came from; payload, the actual content; and context, providing surrounding information like memory type and project scope. The NATS pipeline dispatch begins after the API stores raw data and publishes it to NATS Jetstream. A pull worker picks up the message and routes it. NATS Jetstream provides durable, pull-based delivery, queue groups for efficiency, backpressure handling, and at least once guarantee for reliability. Our 6-layer classification system ensures efficient routing. The router checks each layer in order, with the first match winning. Layers 0 through 4 are deterministic and low cost, classifying most data without needing a large language model. Only ambiguous content falls through to the final layer. We use 42 specialized agents, each tailored to analyze a specific data type, such as documents, media, and spatial data. We employ a 5-tier smart routing system that automatically selects the appropriate model tier. This ensures that simple data uses the smallest model, with 80% of data running on the smallest model. AI enrichment produces multiple artifacts that make data deeply searchable. These include the viewpoint, a structured summary of the content's analysis; embeddings, which are vector representations for semantic search; entities, like people and organizations, extracted and dual-written; and relationships, directed connections stored in a knowledge graph. The embedding pipeline chunks content into 1,000-character windows with 200-character overlap for independent vectorization. We use a cascade strategy for the embedding engine: local Ollama first, then Ollama Cloud as fallback, and finally the Gemini API. These vectors are stored in Postgres via the PG vector extension. Our dual-layer knowledge graph stores entities and relationships across 2 complementary stores. Layer 1 is always on Postgres, handling 8 entity types and basic relationships. Layer 2, using Graffiti and Neo4j, is optional but adds temporal reasoning and LLM-powered entity resolution for advanced queries. We offer 5 search modes, each tapping different indexes: vector for semantic meaning, FTS for exact terms, and hybrid as the general-purpose default, combining both. Graph search is for entity relationships and temporal facts, while full mode provides maximum recall across all signals. We employ 4 re-ranking strategies to rescore initial results for improved relevance, diversity, or precision. Options include none for raw scores, reciprocal rank fusion, RRF, for merging lists, maximal marginal relevance, MMR, for diversity, and cross-encode using an LLM for highest accuracy but increased cost. The final step is RAG chat with citations. This turns search results into a conversational answer with traceable inline citations. The process involves embedding the user's query, running the selected search mode, applying a re-ranker, building a numbered context, and finally, generating an LLM answer with citation markers. Let's look at an end-to-end example, from a Slack message to a query answer. The ingestion and enrichment steps involve normalization, classification by the router, analysis by a specialized agent, and the creation of viewpoints, embeddings, entities, and graph relationships. The query uses hybrid search, RRF merging, and graph boosts to generate a cited LLM answer. Our pipeline takes data from ingestion through classification, routing, analysis, embedding, and extraction into a knowledge graph. We use multiple search and re-ranking modes to deliver answers via RAG chat with citations. This ensures every piece of data is automatically enriched and instantly queryable.